When 5.67 grams of an unknown non-electrolyte is dissolved in 50 grams of water, the boiling point increased by 0.47 degrees Celsius. If the Kb of the solvent is 0.512 degrees Celsius per mole, calculate the molar mass of the unknown solute. First, let's summarize the information given to us and what we need to find. We know we need to find the molar mass of the unknown solute. We know that the solute is a non-electrolyte, and we know that the solution is made by mixing 5.67 grams of the solute in 50 grams of water. We also know that the boiling point elevation, delta Tb, is 0.47 degrees Celsius. Lastly, we know the boiling point elevation constant, Kb, is 0.512 degrees Celsius per mole. So let's first talk a bit about the theory of what happens when you add a solute or dissolve a solute into a solvent. When a solute is added or dissolved into a solvent, there will be an increase in Tb or boiling point. So in formula form, we'll have Tb of solution, which is boiling point of the solution, equals Tb of solvent, boiling point of solvent, plus delta Tb, which is the boiling point elevation. And the formula for delta Tb is I times Kb times m. I here is Van Hoff factor, Kb is the boiling point elevation constant, and m is molality of the solution. So let's talk about what is Van Hoff factor. Van Hoff factor I is the number of particles in solution per formula unit. For example, let's say for sodium chloride, NaCl, the Van Hoff factor I is 2 because NaCl in solution is going to dissociate into Na plus Cl minus. So that's 2 particles in solution per 1 formula unit of NaCl. And another example, let's say sucrose. The Van Hoff factor I is going to be 1 because sucrose, unlike sodium chloride, does not dissociate. Therefore, the number of particles in solution per formula unit is 1. So let's go back to our case. So the boiling point of our solution is going to be equal to boiling point of solvent, in this case that's water, plus delta Tb. We know that the boiling point of water is 100 degrees Celsius, and the delta Tb, the increase in boiling point, given to us is 0.47 degrees Celsius. So now we need to find molar mass of the unknown solute. To do that, let's look at the formula to find delta Tb. Again, delta Tb equals I times Kb times m. We know that I for this non-electrolyte solute is going to be 1 because like sucrose, the solute does not dissociate. Next, we know that the Kb, the boiling point elevation constant, is 0.512. That's given to us. And lastly, the m is molality, and we know molality is calculated by taking the mole of the solute divided by kilograms of the solvent, which is water in this case. So first of all, we know we have delta Tb, we know we have Van Hoff factor I, we know we have Kb, so we can definitely find m, find the molality by taking delta Tb divided by I times Kb. Next, once m or molality is found, we can calculate the mole of the solute from the molality formula. Mole of solute and solute is going to be molality times kilograms of water. Lastly, once the mole of solute is found, we can calculate the molar mass of solute. Molar mass of solutes is going to be mass of the solute divided by the moles of the solute that we just found. So this is the outline of what we're going to do. I'm going to put it in the corner, and we'll start by calculating molality. Again, molality is calculated by taking delta Tb divided by I times Kb. That's going to be 0.47 divided by 0.512 times 1. That's going to give 0.918 molal. Next step is to calculate the mole of the solute. So mole of solute and solute is going to be molality times kilograms of water. And first of all, we know molality, we calculate earlier, is 0.918. And we know that we need to calculate kilograms of water from 50 grams of water. So we take 50 grams, we times 1 kilograms over 1,000 grams. That's going to give 0.05 kilograms of water. Now let's calculate. That's going to be 0.918 times 0.05. That's going to be 0.0459 moles. Once we have the mole of solute, let's calculate molar mass of the solute. Again, that's going to be mass of the solute divided by the moles of the solute that we calculated earlier. Mass of the solute provided to us in the prompt is 5.67 grams, and the mole of solute we just calculated is 0.0459 moles. And if we do the math, we'll get the answer is 123.53 grams per mole. That is the molar mass of the solute we need to find. Thank you for watching.